So this one is Algebra 1, Semester 2. It's a unit called Inequalities Review. It's number 6, and it's a lesson called Solving Inequalities with Plus Minus Practice. It is lesson number 3. It's on creatormath.com under the Algebra 1 tab, and you might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So I'm going to show you where those are. That can be difficult for students to find. First things first, you need the name of the site. It's creatormath.weebly.com. Type that into Google. You should be able to find this homepage. All right, if you have any questions about the composition book, please just scroll down on this home page until you see the words composition book. Follow all the directions, watch all the videos, adhere to the turn-in dates, put things on the pages where they belong, including the notes, which we're going to go to now under the class tab. Under the class tab, you'll find 5 things. You'll find the notes. You'll find the problem set like we're going to do right now. You'll find the video of the problem set, which we're making right now. You will also find the page numbers on which the notes go in the comp book. And you will also find the famous vocabulary practice PDF. This is a PDF with all the vocabulary words we're going to use in this math class for the entire school year. It is downloadable to your device and it is searchable. So Google, how do I search a PDF using whatever type of device you're on? Follow those directions. It's a little bit different depending on what type of device you're on. Next, we're going to go to the semester involved. This is very important because there's different table of contents for each semester. So in this case, we're on semester 2. Here's the important table of contents. It's so important that I ask you to write the entire thing, about 3.5 pages worth, onto pages 2 through 6 of your composition book. Why is it so important? Because it's got the page numbers of where everything goes throughout the entire comp book. That way, when I grade 180 of these, at least I can find it if you've got it, all right? Otherwise, it's a mess and I can't get to what I need, all right? So follow the directions, follow the page numbers, put things where they belong. Now we're going to scroll down to the unit involved. This is Inequalities Review is the unit. And this problem set is the one solving inequalities number 5. Let's see, lesson number 3 here. Let me get that right. Yep, lesson number 3. Solving inequalities with plus minus. Here are the page numbers on which the notes go. Please check. Please don't take this video's word for it, but check the original table of contents at the time you're viewing this. These page numbers probably will have changed. Here will be the notes. They're not here right now linked, but that'll be fixed. Here's the problem set we're doing, and here will be where the video solution is that we're making right now. All right, so with that said, let's go ahead and look at the problems for this section, for this lesson. So let's start out with some warm-ups. Given this symbol, it's like this, right? It is a greater than. This one is a less than. So greater than, less than. This one's shaped like this, right? Just a memory jogger. I know a lot of students know this by now and or have learned it 2 or 3 times. This is greater than or equal to, right, like that. This one's less than or equal to, like that. Okay. On a number line, what does an open dot mean? Open dot means not included. The value's not included. So let's say it's on a 5, right? I always use that example. If it's open dot and it's below, this value is not included, so it's everything below 5. So 4.99999999999, etc., right? And so we just say x is less than 5, and it includes that understanding. All right, let's see what the next one is. What does a solid dot mean? Okay, on a number line, what does a solid dot mean? So now it's on our 5, and let's say it's a solid dot filled in, right? So, and it's less than. This means it includes the value, so the value is included. So this case would be less than or equal to 5 because the equal shows the 5 is also included in this set for x, right? In set notation, what does the parentheses mean? That means the value is excluded. So go back to our open dot, right, with the 5. It's like this and below. This would be a parentheses 5 comma negative infinity. Why parentheses? Because it does not include the 5. It's similar to an open dot understanding, right? It does not include the value. Parentheses in set notation, not coordinate location. That's a completely separate topic. This is set notation. And which way does it go? It goes down to negative infinity forever, all right? All right, what's a bracket mean? Bracket means the opposite. So now I'll go back to this one where the 5 was included. This would have been written bracket 5, comma, negative infinity parentheses as a set notation. Bracket means the 5 is included, so the value is included. And just a note, we use a parentheses on the negative infinity here because infinity is not a number, it is a concept, right? So the parentheses has to be used on any infinity, not a bracket. You can't include it. It's not a number. All right, so let's see what else we got. How's this read? Positive infinity. How's this read? Negative infinity. So just think of a horizontal number line. There's a 0. There's a positive infinity off to the right and a negative infinity off to the left. If it were a vertical number line, right, it would be positive infinity up forever, and it would be negative infinity down forever. So we use 2 number lines. We use the X for horizontal, and we use the Y for vertical. That's always the same, you guys. It never changes. It's a foundational principle of the Cartesian coordinate system. All right, so is infinity a number? No, infinity is a concept. Think of a number as like 5 billion, and that's big, right? But is that infinity? No, because you could go to 10 billion, and you can go to 50 billion. And whatever number you name, you can always go bigger to get to infinity. That's why it's a concept. There is no single number for it. It's just the concept that it's ever increasing, either positive or negative, forever. All right, solve the following inequality. All right, let's get into inequalities. It's just like equation solving, all right, with some twists along the way. Let's add 4 to both sides. X is greater than negative 2. So x is greater than negative 2, right there. Oh, they're giving us set notation too. If x is greater than negative 2, it's from negative 2 up to positive infinity. You need a parentheses because there's no equals. Well, you need a parentheses because there's no equals for the 2. You need a parentheses because infinity is not a number on the infinity. All right, let's do this one. X plus 8 is less than negative 14. Go minus 8 and minus 8 on both sides. X is less than, we're keeping the symbol the same, minus 22. So x is less than 22. That's one answer. And if you put it in set notation, you would have a parentheses, negative 22, comma, negative infinity, parentheses. So 2 parentheses, negative infinity, comma. I'd like to see a negative here. Negative. So we'll fix that by the time you guys take it, okay? All right. It's a typo, all right? Solve the following inequality. Let's see, x minus a minus 7 is greater than or equal to minus 22. So this is the same as x plus 7 is greater than or equal to minus 22. Minus 7, right? So x is greater than or equal to minus 29. X is greater than or equal to minus 29. And if x is greater than or equal to, we'd have a bracket minus 29, comma, going up forever to the right, bracket minus 29 plus infinity parentheses. Remember, these are not coordinate locations. That's a separate issue. Remember the old days? You'd have 3, comma, 5. You'd go out 1, 2, 3, and you'd go up 1, 2, 3, 4, 5, 3, 5, and put a point. That's a coordinate location. This and this, totally different, you guys. This is called set notation. And I'm sorry, on behalf of all math, that we use the same symbols, and we just use them in completely different contexts, all right? It's very confusing sometimes for students. You just got to learn it, all right? Life is full of shades of nuance, and you can navigate it if you just think through it a little bit, all right? So go ahead and just think through it, and I know, I don't like it either, all right? It bugs me too. But in the end, I'm fine with it, because math gets to be what math is, all right? So let's subtract 6 from both sides. X is less than or equal to 6. And flip it, folks. X is less than or equal to 6. Remember, when you flip something, you flip the entire statement. The X moves over here, the 6 moves over there, and the symbol must flip. So it went from the small end, right, toward the X. The small end stays toward the X. That's essential. So X is less than or equal to 6. And if you put this into set notation, here's your 6. Less than or equal means bracket, it's included, and it's going all the way back to negative infinity forever, and it's a parentheses because it's infinity. So this one here too, 2 answers. By the way, that takes me back to this one. We said bracket negative 29 plus infinity is this one. And we said this one too, although we're going to fix it. Okay. Well, for whatever reason, that looks like it. It goes up to number 15, I guess. So make sure you're matching the title of this video with the problem set you're doing. Otherwise, it's not going to make much sense. This is Algebra 1, Semester 2. It's a unit called Inequalities Review, number 6, and it's a lesson called Solving Inequalities with Plus-Minus Practice. It's the third lesson. It's on creatormath.com under the Algebra 1 tab. Hope this helps.